Another way we classify matter is by looking at the physical and chemical properties and any sort of physical and chemical changes that matter undergoes. So we're going to start by defining the chemical and physical properties, and then we'll look at chemical and physical changes. So a physical property is something you can observe or measure without changing the chemical composition. Without changing the chemical composition. Okay, so whatever it is you do to the matter, it's exactly the same as what it was when you started with. So a chemical property describes how one substance reacts with another. Right? So describes how one substance reacts with another. So describe if a reaction happens. It can also describe if a reaction is not going to happen, like something does not react with something else. Or it could tell you that one particular thing does react with something else. And when we say that it reacts, what this means is after the process happens, you form a new substance. So when something reacts, we form a new substance. Okay, so let's look at the following and see again if we measure or observe this, if we would be changing the chemical composition or not. Okay, so the color of an object. So if we take my trusty Legos here, we could observe, looks kind of orange here, but this is red. We could observe that this Lego is red or red-orange, and I didn't change the composition of the Lego. So this is physical. Okay, so we could measure the density of something. So the density is the mass over the volume. So taking a mass measurement doesn't change the Lego into something else, and measuring its volume also doesn't change it. So this is also physical. Okay, so next one we have flammability. So the flammability is the ability to burn. So for example, if I took this Lego and I lit it on fire. So kind of think about that. If I took the Lego and lit it on fire, would it change the Lego into something else? And the answer is yes. This is chemical. Okay, so solubility, dissolving into something. Okay, so maybe my Lego, not the best sort of example of this, but think of putting sugar into water. So when you put sugar into water, what happens? Okay, so generally speaking, if it's going to be a chemical change, we form a new substance. So my Lego would be all burnt and melted, and some of it would sort of turn into gases and escape into the atmosphere. So definitely something new has happened there. If you think about solubility though, with sugar, once you dissolve it into water, you can just boil the water away and recover your sugar. So this is a physical property. Because again, think about our lessons on mixtures, and we talked about how like a sugar water or salt water solution, you could recover that by again boiling the water, something like that. Reacting with an acid. So we're going to see some chemical reactions in chapter 7. An acid is something you see all the time when chemicals are transported. They tell you if it does react with acids or not. So that's chemical, because again, it's describing a reaction. Sour taste. So just tasting an object, the taste of an object is physical. The melting point, so measuring the temperature at which something goes from the solid phase to the liquid phase. Okay, so if our substance is water, for example, H2O as a solid or H2O as a liquid, it's still H2O, so that's physical. So it definitely looks different. We've changed states, but we haven't changed the water into something else. Does not react with water. So lots and lots of things out there do not react with water. That is also chemical. So describing how something does react or does not react is a chemical property. Luster, that's shininess. So this is physical, to see if something is shiny or not. And hardness, same thing, physical. So if you look, a lot of the things you'll encounter when you are looking for properties, a lot of things that would be considered physical, you can kind of look at what we saw. Color, density, solubility, how something tastes, how something smells, or odor. Melting points, MP, melting points. Boiling points, same thing. Or, not same thing, but similar type of process. Temperature of melting, temperature of boiling. So a lot of these, or when we looked at our density, you can measure the mass of something. You can measure the volume of something. You can measure the temperature of something. So these are all things you can do without changing the substance. If we're to look at chemical, so a lot of the things we see in chemical are flammability. Another one we see is the reaction. So RXN, that's reaction with acids. And also in chemical, no reaction can be a chemical property as well. So these two are pretty common. And like I said, when chemicals are shipped, these are the two things that are generally reported. But we're going to see down in this sort of other section of this that it's not just confined to these three things. Anything that reacts with anything else would be a chemical property. Okay, so again, these are two very common ones we run into, but there are many, many, many more. Okay, let's go down here to the bottom portion of this. Now we're going to look at physical changes and we're going to look at chemical changes. So a physical change is just a change in appearance. So just a change in the way something looks. A chemical change is a change in chemical composition. Okay, so it was one substance before and it's a completely new substance after. Okay, so let's look at some examples. Identify the following as physical or chemical. Okay, so again, we're looking at just looks different or has completely changed into a new substance. Ice cube melts in the sun. So we've just gone from solid water to liquid water. That's just a change in the way the water looks. It's still just water, so that's physical. Mixing baking soda and vinegar together to produce gas and foam. So we have a solid and a liquid and we mix it together to make a foam. We have definitely made something brand new there. So that's chemical. Again, it sort of indicated that by we had a solid and a liquid and we mix those together and we make something that's a gas. So it very much looks like it has different properties after we mix them together, meaning a chemical change has happened. Okay, so next we have a nail rusts outdoors. So it's changed color, it's changed composition just by being outdoors. Turns out the nail is iron, it's reacting with oxygen. This is chemical. So it's turned into something else. The iron nail has turned into this compound called rust, which is iron oxide. Okay, next we have a rock and we crush it into fine particles. So whatever the rock was made of before, it's still made of that same thing. It's just going from a large size to a much, much smaller size. So this is physical. Next we have sugar burning on the stove. So sugar burning on the stove means it's reacting. It's reacting with oxygen. It's changing from whatever sugar molecule it was into something else. So this is chemical. So next we have dissolving salt into water. So remember up at the top, solubility was a physical process. So taking salt and dissolving it into water, we're just making the salt look different. Went from being in our, salt shaker at home, now it's dissolved into the water. But again, if we just boil that water off, we can recover it. That's physical. It's still salt, it's just now in water instead of by itself. Okay, next one, we take two liquid substances, we mix them together, and we make a solid. Okay, so we have two liquids, and then they come into contact and they change into a solid. So they've changed their properties completely, which indicates we've made a new substance. So this is chemical. And next we have, or finally we have alcohol is evaporated on the stove. Evaporation is just another word for boil. So we saw up here, boiling is a physical property. So the temperature at which something boils is a physical property. So the actual act of boiling would also be a physical process. So physical. So a way I like to think about these is when you're sort of going through and seeing if something is physical or chemical. A lot of times you can get there by thinking of physical. So something, a process that is physical can be reversed pretty easily. Okay, not all the time, like it would be tough with our rock to reverse it. But with our melting, we could just refreeze the water, that's pretty easy. The rock would be more difficult to put together, but the salt dissolving into water, we could just boil it. And again, we can just then condense the alcohol back into a liquid. So those are pretty easy. A lot of things that are chemical, so think about the reverse process would be difficult. So these are generally difficult to reverse. So if we look at these, having that gas and foam that's produced from our baking soda and vinegar, it'd be really tough to take that gas and foam and try to recombine them to get our baking soda and vinegar back. So that's, again, chemical. That would be really hard to reverse. Our nail rusting, again, it would be difficult to take this and go in reverse to get our nail back. Burning our sugar after the sugar is burned. If you've watched any sort of baking shows like I have, you know that they have to throw that sugar away and start over. That's really difficult to reverse. And again, same thing here. This process is difficult to reverse this way. So again, a lot of times if you are stuck, coming back and looking at in a physical process is usually easy to go and reverse and recover your substance back. Chemical is not, because you are making brand new substances when they combine.